Okay, guys. So today, we're going to talk about inheritance. We're going to probably talk about interface on Thursday. So this is slides for the class tonight, but we are going to talk about inheritance today. So what's the plan for today is we're going to review some basic object-oriented programming concepts, including object, class, instance variables, and instance method. And then we're going to talk about inheritance. That's a plan for today, and after that we're going to have lab time. Okay, so instances are objects. So what are they? So the definition of an object is that it's an entity that has state, behavior, and identity. So basically, you can think of, like in computer, object is represented as a group of data, so data entry. So the state of the object contains is composed of object properties. For example, if we have, like, say, animal class, and let's say we have an instance of an animal, say dog. So the property or state of the instance would be like the name of the dog, for example, it's Foggy, and its gut, which is a list. So that's the property of the object.
And if I could just jump in for a minute, the idea that Ewing describes are state, behavior, and identity. The book doesn't use exactly those terms, but that's really sort of an important concept to think about. And I'll ask Ewing to point this back. Try to keep those three words in mind, because objects always have a state. They have behavior, what the user can do with that class, what it can do with an object of that class. And then they have an identity. And what have we been calling their identity so far? We've been calling it a variable name. When a variable is an instance of a class, that's really how you identify it.
Okay, so our object has its own state and some behavior. So for states, we know it's the variables that we define in the class. For the behaviors, these are the methods. So for instance, our animal class, if I can plot here. So in this case, we have the name and gut as the property of the field variables of the animal class. And greet, eat, and excrete are the behaviors of an object in the animal class. Okay. So to create or to instantiate a class, or to create an object or instance, you need to use the keyword new and the constructor of that class. For instance, before we talk about the stream reader object, so what we do is we specify the class, which is stream reader, and we give a name, which is the identifier of the variable, and we use this new stream reader, this keyword and this constructor to create an object of the stream reader class. So what is a class? A class is a group of objects that shares common state and behavior. But keep in mind that a class is described or gives an abstraction of an object instead of an actual object. It gives a blueprint. So for instance, in the animal class, it gives a blueprint of an animal. It has a name, it has gut, but it does not give us any specific animal like Foggy or dog that we wrote in the...
Who can identify here animal's state? Where are we storing the state, the current condition of the animal? What part of the code represents the state?
Is it animal?
Well, the whole class is called animal. Where is the state of the animal kept?
Public animal?
Well, okay, but that's the whole program, right?
This is the constructor that we use when we instantiate an animal object. So what are the states of the animal? Like for an instance of animal such as Foggy. What are the states? name, yes, that's one of them.
Got it.
Yes. So these are instance variables. They supply the mechanism for us to keep track of the state of an object. Okay. So class defines data and behavioral instance of these classes. So we gave the instance variables, which are name and gut, and those behaviors such as greet, exit, and eat. And class is not object itself, it's only an abstraction, but keep that in mind. So to declare class, what we need to do is we say public class, my class, and then we need to have these pair of curly bracket, and we put the field variables, method, and other code in the class. All right, so what is instance variables? So instance variables are sometimes in other programming languages are referred as class attributes, class fields, and variables, and class variables. They are bounded to instance of that class instead of the class. So what do I mean by that? So in our animal class, if we instantiate an animal, let's say Foggy, name and gut are associated with the object Foggy instead of the class. So class animal does not have its name, does not have its gut. You must have an instance that actually can have the name and the gut. However, you notice that these variables, instance variables, do not have the keyword static. If you remember what we did before, we always have something like public static int number like that, or public static void my method, something like that. Instance variables are not static, so it means that they're not associated with class. If you say something is static, that means it will be associated with a class instead of instances of that class. So instance methods are the methods that can only be invoked by animal or by the instance of the class. So for instance, we have a class dog, and this dog, so for instance, for this case, we have a public static string get genus, and because all dog belongs to canis genus, that means we don't need, so this is associated with a class. It does not need to be associated with an individual instance of dog. So Foggy belongs to canis, other dogs all belongs to canis genus. However, for this case, for this bark method, because we need a dog in order to make it bark. An abstract dog cannot bark. Therefore, this is an instance method instead of a class method. All right, so that is a brief review of what we learned before about object-oriented programming. Any questions? All right. So there's a different type. There's two fundamental types in C#. Before we talk about something like ints, double, boolean, or byte, those are or char. Those variables are called value type. Well, those types are called value type. Means that they actually, if you declare it, it actually holds its data in its memory address, and it cannot be referred by other variables. However, for all the classes that we declared so far, like animal, like stream readers, these are reference variables. Means that two variables can refer to the same thing. Why do we need reference type? Well, reference type came from pointer, which was mostly used in C and C++. It was low-level languages. However, they cause a lot of issues, so especially like memory management, which we do not need to do in C#, but for C and C++, it's a horrible thing to do. So using reference type, we can avoid a lot of errors, unnecessary errors in our program, so that our program will be more reliable. What's the difference, how they look like in the memory? So for instance, I declare int age5. What I have here in the memory is the type will be int, the identifier will be age, and the 5 is right in this memory address. However, for a reference variable such as string, such as like string name, what happened here is when I declare string name Tom, the computer gave me this allocate a little memory address for holding this reference, and gives me the type and this identifier, but the value Tom is stored somewhere else instead of this part of the memory. And then if I declare something like string Tom name equals name, what the computer will do is it gives me this string and allocates this address for me. So first it's going to look for what name goes to, and since name points to Tom, so it will finally point to Tom. So that's what we call this reference. So they are both the two different variables, but they can refer to the same thing. All right.
Which can cause a heck of a lot of trouble.
In C and C++, yes. In Java and C#, we don't need to worry about that much. Okay, now we're going to talk about our new things today, which is inheritance. So, here's the problem. So far we have had our class animal. And now we want to have more classes, like dog, cat, cow, horse, etc. They all have similar attributes and behavior, such as they have name, they have their own gut, they can greet, eat, and excrete. So the problem is, do we need to implement all these classes? Can we use some of our code from the animal class? So yeah, it doesn't hurt because animal class is a very small class. Like, it doesn't hurt that we copy and paste and do a little bit of adjustments to the code. But it turns out to be very tedious, especially for large projects. So the solution is we have the inheritance thing. So what does the inheritance do is, inheritance allow us to create a new class based on some class that we already established. So the definition is class can be derived from other classes, thereby inherited fields and methods from those classes. So if we give an inheritance, if we want to create dog or cat classes, instead of rewriting everything from scratch, we just inherit everything from animal class and do a little bit adjustment so that the behavior of dog and cat match themselves instead of just a generic animal behavior. So in inheritance, in order to have inheritance, we need to have two classes. One is called base class, and the other one is called derived class. Base class is where we inherit from, and derived class is what we get. Derived class are also called subclass, extended class, child class, in other programming language terminologies, but in C# we call it derived class. So base class is more often called as superclass, which is where we inherit from. So, but there's an exception in C# and Java, is that all classes in C# or Java are inherited or derived from the class called object. If you look up, probably not in Microsoft's documentation, but in Oracle Java's documentation, probably you will see that they are all inherited from the object class. So inheritance in C# has a little bit of features. The one thing is it's single inheritance. So every class must only can inherit from one class at a time. It cannot inherit from two classes simultaneously. We'll talk about that later when we talk about interface. Inheritance is transitive. What does it mean is that if class C inherits from B and B inherits from A, that means C not only gets attributes and methods from B, but also everything from A. Okay, so what does inheritance look like when we actually do it? So we start from a base class, such as animal, and then we can derive some other classes, a little bit more specific and specialized classes for animals, such as dog, cat, horse, and cow. They all belong to animal. And then, when we have these classes, we can derive a little bit more, give more specialization. So for dog, we can have husky dog, shih tzu dog, and other kind of dog. Cat, we can have tabby cat, maybe other kind of gray, white cat, black cat. Horse, we can have Tennessee Walker House, and cow, we can have Holstein cow, for example. So base classes, such as animal, dog, they give the fundamental abstraction of that kind of data. They're very raw in that term. So basically, they just give a very rough blueprint, and then we have to derive, or we use inheritance to get these classes, give a little bit more specialization for dog, for animals. Any questions about this picture?
Can anybody think of a way to add other parts to this diagram? So we have an animal at the top. What else could you add? One of the advantages of object-oriented programming is once somebody has produced a structure like this, other people can come and add it. So Ewing's structure has dog, cat, horse, cow. I might want to add at that same level, maybe fish, insect.
Maybe not.
Maybe not.
Animal is not insect, they're kind of different classes.
Okay, so we could add a fish. We could add chimpanzee, or maybe the right word would be, let's see, what category are chimpanzees in? Somebody help me out here?
Monkeys.
Yeah, okay, monkeys, that would be a good one. And then down below, I could add several kinds of monkeys. And so the idea is that once you've started a hierarchy like this, not only you, but other people can expand it. And they get the advantage of all the work you've done without having to duplicate anything.
So how do we tell the relationship between classes and inheritance? So there are two relationships among classes in programming languages. So the first one is called is-a relationship. What does it mean is that derived class is a specialized case of the base class. In our previous example, we had dog, cat, horse, and cow derived from animal. So therefore, we can say dog is an animal. It's not proper like English, but that's what we use. Cat is an animal. But we cannot say animal is a cat because cat inherits from animal. Unless you make animal inherit from cat, which is unnatural for us. So, and then for this level, we can say husky is a dog, but dog is not a husky, or dog not is a husky, because husky is a specialized case of dog, and dog is more general.
Right, or another term I like to use is a husky is a dog, and a dog may be a husky, but a dog could also be a wolfhound, a dog could also be a beagle, a dog could also be a et cetera, et cetera. And so the way this works is as you're going, I always think of it as up the inheritance hierarchy, everything is a. Husky is a dog, dog is an animal. Coming down the other way, you don't know for sure. An animal could be any of those. So the best you can say is an animal may be a cat, it may also be a horse. A horse may be a walker, or it may be a runner?
Yeah.
Whatever.
So, so because all classes in C# are derived from the class called object, so therefore it's safe to say that every class in C# except object are an object or is an object. There's another relationship called hazard relation. What it means is that classes has instance variables that are from other classes. For instance, in our animal class program, we have one of the instance variable, name, has a type of string. Therefore, we can say animal has a string. It just denotes that
Animal has a name, I would say, not animal has a string, right?
I would say it has a string, or
Okay, we'll talk about that.
it contains, like, it reflects that string class is included in animal, or I should say, string is used in the animal class. But string is not animal, and animal is string not is an animal, or we cannot say, or vice versa. All right, so a little bit more details about inheritance. So derived class in C# implicitly in all the members of the base class, such as instance method instead of instance variables. So if we have the dog class which inherits from animals, well, the dog class will implicitly get name, gut, greet, excrete, and eat. Derived class, it has its own specializations, so it can have its own instance variables that are not defined in the base class, and it can have its own instance methods which are not defined in the base class. And of course, because every class in C# inherits from the object class, and object class contains these 4 methods that we're going to typically use. So therefore, all classes in C# contain these 4 methods. Question?
So all the classes have to be in the same project? Or
You mean
how do
in Xamarin? Like in
So it can be in any project of your solution?
I don't know about that. I mean, I don't use
Yes,
Xamarin.
and you even know the answer, because how we've been using UI or UIF, it's a class. Right, and so as long as you've got access to it, either because it's built in like, well, UI we've added, right, UI and UIF. Console.WriteLine is built in too, although it's
Yes.
static, it's not quite the same.
Like
When we did file I/O, you were using built-in classes that defined objects. Remember, we made like a file object, and that really was built in, and you can use them from anywhere you have access to, either built in or when you add to your solution.
Okay, but so we talk about the inheritance that gains everything from the base class, but that does not mean that the derived class can access everything from a base class. So if you have noticed before, we had those like different modifiers such as public, protected, we probably have not seen that yet, and private. What does that mean? So for public variables or methods, that means any code that is within the project can access that. So if it doesn't have to be in the same class, it can be 2 different classes, but this class, the member of this class, can access any public member of the other class. For protected variables method, is that only derived class can access protected members. For instance, if I have class A, and then I have a class B derived from class A, so class B can not only access every public members of class A, but also those protected. But if I have a class C that has nothing to do with class A, can only access the public field instead of the protected. And private is a little bit more restricted. So for private variables and methods, that means they are only accessible within a class. For instance, if I have class A and class B derived from class A, and then I have a class C has nothing to do with class A. Class B can access protected and public instances, or I should say variables and methods. But all those private variables and methods can only be accessed within class A instead of class C or B. So now I think it's time to give you a little bit demonstration of how inheritance works in C#. So what we're going to do is we are going to implement the dog class based on what we have in the animal class, and we're going to add a little bit features or specialization to dog class, such as we can make dog bark, we can assign an owner to the dog, and dog can have its own greeting fashions. Okay. So we will start. So in order to make this work, we'll need to start with a class that we already declared and implemented. So in the animal class, we have the instance variable name with protected, means that I want to access this variable in all the derived class of animal. And God, I don't need to access that in any other derived class of animal, so I can keep it private. In the constructor, we just initialize name and God of an animal. And for animal, we have this public method. We have this get name, which will give us the name of the animal. We'll have this greet, but you'll notice that there's a virtual modifier. We'll talk about it later. And we have this eat method from the animal, for the animal that basically append an item to the God. And then we have an XGreet. So basically what this code do is if the list of God is not smaller, or I should say if the list of the God is larger than 1, that means we can XGreet things, otherwise there's nothing will happen, so we'll return no. Okay, so how do we build our dog class? We start by defining the class, declaring class, public class dog, and we need to have this column operator, which tells us which class that we want to inherit from. So in this case, we inherit from the animal class. And derived class, like I said, can have its own instance variables. So in this case, we can give each dog an owner. So each dog will have its own owner, and we will initialize it as unknown because it's a natural thing to do. And constructor for the dog class, we need to notice that inheritance in C# does not, or Java does not inherit the constructor. So we need to redefine the constructor. In this case, this constructor in the animal class is good enough. So we don't need to do anything about it. So what we do for our constructor for dog is that I use this column operator again and use this base name. What it tells the program is that I use the same argument as the animal class, which is name, but instead of implementing my own constructor here, between the bracket, curly bracket, I say base name, which means I'm going to use this constructor to do it for me instead of implementing my own one. And because derived class implicitly gains all members and methods of the base class, therefore I do not need to define this method or eat method or XGreet method in the dog. All I need to do is add some specialization. So for instance, in this case, I make a dog can bark. So when a dog bark, I just print out bark, bark, bark in the console. And however, I want to make a dog a little bit different from an animal. So I modify or override the greet method from animal. As in the animal class, the greet method what the greet method is doing is that it just say, hi, my name is some name. But for dog, because I want to make it special, I would say, bark, I'm someone, bark. Bark, my master is something, bark, bark. So it sounds more like a dog instead of just a normal animal. And then it's another method that I can add to dog, which is set owner. So what the program does? How will we use this dog and animal in our executable program? In this executable program, I first give some prompt that I can enter some name for animal and dog and enter the owner information of that dog. And then given that I have the name of dog and animals and the name of the owner, I can start doing something like this. I can declare an animal, or instantiate an animal, instantiate a dog with the name that I get from user input. And then I set the owner of the dog by with the owner name that I got from user input. And you can see, because dog inherits from animal, therefore animal in this instance A can greet. This instance of dog can also greet, because dog inherits from animal, so it gets everything from animal. Now similarly, both animal and dog can eat. This animal may only eat grass and more grass, but this dog is a little bit weird. He likes to eat crabs and fish. And here, because I also defined the bark method in the dog class, therefore a dog can bark. However, the animal cannot bark because dog inherits from animal, and bark is only defined in the dog class instead of the animal class. Base class does not gain anything from the derived class, but derived class gain everything from the base class. Therefore, a animal cannot bark, but dog can bark.
So let's take a minute here. I want to ask the class a question. You Bing will answer if nobody else can. But so let's look at this AD lines of eat here. Let's talk about plain computer when we call a.eat grass. You Bing will run the mouse. Let's find the code that will execute when we might have to show them the declaration of A again. A is a animal. Animal A is a new animal. Wait, no, what's the animal name?
Animal name is from user input, console read line.
Okay,
yeah.
Good. So we don't know the name, analyze the name. Okay, so let's go down to a.eat. What code is going to run when we tell A, an animal who the user has named, to eat grass? Scroll around, maybe give them a hint. What code is going to run for a.eat?
Do you want me to go to this?
Anybody see it? Everybody see it? Point, you big.
So it will be this method will be executed.
Everybody remember that's line 34 and 35. Right? Within the class called
Animal.
animal. So now let's go look at d.eat. What code is it going to run? Anybody know the answer?
Same one.
Same one exactly. Now, let's do that same thing for greet up above. Now, what code is going to run for a.greet? Well, let's go look. We'll find greet. And so we're going to run line
26, 27.
Really. And we're going to say, hello, my name is whatever it was, Froggy or whoever. Now let's do the same thing for our dog. What code is going to run for d.greet? This time it's not the same.
The one dog.
And now we'll go into the dog class, and we'll do this new greet, which because it's overridden the old greet will run instead.
So you have to have the override there?
Check out the old.
No, like you have to have the override for.
C# does require the override.
If you want to modify it, you can use the override. And if you want to override it, that means this base class, this one must be virtual. not every method can override. For instance, I cannot override this eat because it's not virtual.
So
But
what
can you
that's-
just make another eat? It's, you'll make it longer though?
Actually not.
I don't think so. C# is a little
what
weird.
this is saying, the way it's written right now, is the designer of this set of classes about animals and dogs and so forth. I said, I want all animals to eat the same way. And somebody who comes along later like me and doing fish, they are not allowed to make fish eat differently than animals. They are, because of virtual, they are allowed to make fish greet differently than animal. And so again, the creator of the class exerts that kind of control on other people using the class, or if they use it themselves, they control what changes they can make.
Yes, this is a little bit different from Java. In Java, you can basically override anything you want, except those methods are specifically declared that you cannot override at all. But in C#, like you have to tell the method that can be override, so you have to give it's virtual in order to make the derived class be able to override this method greet. Okay, now let's execute the program. Okay, so it gives me the prompt for animal name. I probably make this.
Froggy is our traditional.
Let's see. I want to make the font size a little bit larger, but oh well. So, for example, I give the animal name, which is Foggy, and I give the dog name. Let's see. For example, Hans. And the owner of the dog Hans would be, let's say, Tom. So let's go back to our program. So the first thing the program does after reading everything from the user input is it instantiates animal and dog and set the owner of the dog. Then animal and dog greet. What does it look like? When animal greet, it says, "Hi, my name is Foggy." And then when dog greet, it says, "Bark, I am Hans," and "Bark, my master is Tom, bark." So it's a little bit different, although they invoke the same method, but they're different because dog override the greet method from animal. And now we have animal and dog eat grass, eat crab, and more grass. And then we call dog bark, and you can say dog just barked. In here, we make both animal and dog excrete. So when animal excrete, you see the faces of Foggy. The faces of Foggy is grass because Foggy eat grass first. And then we see D excrete, means we're going to take out the first item that dog eats, and which is crab. So as you can see, the all called eat method, they can all take the same or same type of variable, which are strings, and they add to different lists, different gut, because animal has its own gut, and dog, because it's inherited from animal, has to also have its own gut, and because they are instances, they're not associated with class. Therefore, D and A has their own gut, which are two different lists, and because they are added to different lists, therefore, they excrete different things. Any questions for this? And by the way, this program will be posted, well, I should say uploaded to Sakai after this lecture. So if you want to tweak a little bit more, play around with it, go ahead. All right. So a little bit notes on our program. So in order to inherit something, you need to use this column operator, and everything on the left part of the column is the same, like when we declare class, and everything between the column and this left curly bracket, we put our the class that we inherit from there. And only method that has a virtual modifier can be overridden in the derived class. So therefore, if you ever want to override something, it's better to check whether or not that method in base class has the virtual modifier. Otherwise, you cannot override it. Means you cannot customize or specialize it for your new derived class. Derived class cannot access private members. So in our case, I don't think I have to show here. Yeah, okay. Yes. So here, in this greet method of the dog, I can actually access the name of the dog by using this name. This is because the name instance variable defined in the animal class has a protected modifier. That means as a derived class of animal, I can refer to that instance variable easily. I don't need to, it means, or I should say it's visible to this derived class. But I cannot refer to this variable in the dog class because it has a private modifier. Here, owner is, although it's private, but since I only refer to this owner in this dog class, that means it's not a big deal. But I cannot use something like the owner. I cannot do it. For example, like say string O equals the owner. I cannot do it. The compiler will not let me to do it because owner is a private member. I cannot access this from any other outside class. Okay, so how is inheritance supported in different programming languages? Some languages like C, which is mostly used for low-level programming and operating system implementation, does not have any inheritance support. So you cannot do this cool inheritance thing in C. Some languages like Java, C#, and Ruby, they only support single inheritance. Means that they can classes in those languages can inherit and only inherit from one class at a time. They cannot inherit from 2 or 3 classes simultaneously. However, for some other languages like C++, Python, or Lisp, or actually Common Lisp, they support multi-inheritance, which means one class can inherit from multiple classes at the same time. That will be an issue, very, very bad issue. We're going to talk about in the next lecture when we talk about interfaces. Inheritance is mostly common among object-oriented languages. Like I said, C is mostly for system programming. It's not an object-oriented programming language, so it does not support inheritance. So far we were talking about inheritance really helped us to reduce writing redundant code or unnecessarily inventing the wheel. But inheritance increases the complexity of your code. So especially for multiple inheritances, we're going to talk about that next lecture. Why is so I can give you a little brief thing about brief introduction of the complexity. So suppose you have one class C inherit from B, and then B inherit from A. So therefore, C gets all attributes from B and A. And then when you try to instantiate something, let's say A. So you can instantiate a class A by using, say, new A curly parentheses, Or you can also do something like A equals new C, because C is an A. So therefore, that can cause a little bit complexity in the code because you cannot really tell what exactly that object is. But we're going to talk about it later. So that's all for today's lecture. We're going to start doing our lab.
Yep, and I have one other comment. If you put back up your slide where you first showed the hierarchy with dog and animal, just to relate this back to UML, we were talking about UML as a way to structure these, and so in UML, there's just one more thing you have to learn. So in UML, remember the 3 parts, which with Eubing's help, we can think of another way to call them. This is the state, and this is the behavior, and this is the class name. And so if, in fact, let's put the animal here. So if this is animal, we would make dog here. And this would be Isa. And we'd fill in all the normal parts of animal here, just like we did before. Who can tell me what we would have to put down here in dog? And you're going to put the code for dog up. So what would the private state or private attributes be for dog? There's only one. So we would say here private string owner. And how many public methods does dog have? Well, I see one called bark. I see one called greet. And actually, there should be a constructor too, although in this case, I don't know whether people would put the constructor in UML or not. You probably wouldn't, since you're saying it doesn't really have a unique constructor. So we would say here public. And what are the name of the dog's public methods? There's 2. What are they?
There's 3. Set owner.
Set owner. Sorry. What are the name of the dog's public methods? Bark. Which, oh, we should do it right here. Void. Bark. And what else? Public void greet. And finally, public void set owner, which takes a parameter of a string for the owner. And so, you know, maybe this is a lot to try to take in, but you being Catherine and I are happy to be your consultants in working on your custom project over the next week or 2. If you want to try to use some inheritance hierarchy, we really encourage you to do that. And I guess on Thursday, we'll do the other part of it, which is a little, I never know whether interfaces are easier or harder than inheritance. What do you think?
Easier.
Easier, okay. So then if you don't want to do a whole inheritance hierarchy, you can also use this thing called interfaces to simplify your programming as well. We'll talk about that on Thursday. So any other questions on inheritance? Who can tell me something key that you learned about inheritance today? How do you write it in almost said Java, C#? What else can you tell me about inheritance?
I learned about Virtual.
Virtual, which allows somebody else to override, right? And that's what you need in this kind of structure. If you want down here to repeat something, or maybe another word would be to refine something that the original class did, the base class did. Who else learned anything? What's the syntax? We always were in C# about semicolons and curly brackets. And what's the key syntax here? Colon, right? And the colon goes, in effect, to this arrow. You say dog, colon, animal. And that says a dog is an animal. And that's the way I like to read it, just like I like to read that. Those two lines as becomes, blah, 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 something becomes a value. So try to read this colon as dog is a animal. And remember the other part of it is, are all animals dog? Of course not. Dogs might be able to do anything, or dogs can do everything animals do, but not all animals can bark. Anything else about inheritance? Anybody think of a way you might want to use that? Another example other than animals and dogs and cats. How about something in book list, which we're about to work on? We talked about it, right? We have multiple kinds of books. What if you wanted, in addition to listing books, you wanted to say certain books are nonfiction books, and certain books are periodicals, and certain books are reference books? You could have all of those inherit from the book class. Okay, any other questions we can ask you? Again, this is a lot. It's sort of an advanced topic for the class, but it's really helpful in doing your programming. It shows one of the reasons that object-oriented programming is so popular.
For the dog that excrete,
Okay.
does it have a gut still?
Yes, dogs still have guts because inheritance implicitly gains every member and method or instance method of that base class. So gut is.
But it's private here.
It's private here
So,
means.
okay.
Yes, it's private means that you cannot access that variable in the dog class, but
if we go up to the animal class, not everything is private, right?
yes, but you can. Yes, you still can excrete, but it's just invisible to you. You still cannot call the method, but you cannot redefine it. You cannot access what the data structure behind the excrete method.
Yeah, so scroll down just a little bit. And since the animal has public excrete, public eat, a dog is an animal. A dog has a gut. A dog has a name. Now you can't access it because they're private. But an animal also has a public excrete method. It's public, so you can access it. Likewise, eat and greet and so forth. So this is how these complete structures of object-oriented things are built and what makes them so powerful. Because again, once people have started to set this up, you can use it all, and it just sort of works magically. Okay, with one exception, our teams stay the same. I'll pull up, I'll look here at my list.